Hello everyone, Aaron here, and welcome back to Leetcode. Today we are doing the My Calendar 1 problem. So, jumping right in, we have been asked to implement a calendar that prevents us from double booking. So basically, for example, if I have something that goes from 1 till 4, but I have a booking that comes in to go from 3 till 5, that second one should be rejected because I'm busy in some of that overlap. So here we see, for example, 10 to 20, 15 to 25, that second one should be rejected, but that other one is okay. So this looks to be a inclusive-exclusive kind of thing. I start at 10, but I finish just before 20. Just a moment. Okay, so this thing isn't ever going to get terribly big. We'll make it most 1,000 calls to book. What that tells me is we don't need to do anything super fancy. So basically, in my head at the moment, I have two ideas on how I might implement this. The quick and dirty and easy way to do it, which is probably what I'm going to do, is I'm just going to maintain a list. When I get a new booking, I'm going to start scanning through the list. If I can slot in, I will slot in the booking. If I cannot, I reject the booking. The other way I was thinking of doing it is I might be able to do a kind of binary tree, but rather than the nodes being a single value, they are the range. So we would have, the first value we'd insert would be 10 to 20, so our root node would be 10 to 20. And then we'd have to insert 15 to 25. Well, we would try and dig down into this particular node, and we would see, well, actually, this is a child node. We're busy, so that's rejected. The other one would be 20 to 30, and we would see that, well, actually, 10 to 20 and 20 to 30 can coexist, so I'm going to create a new parent for those, and it will go from 10 to 30. I don't know if that would work, but that's just an idea off the top of my head. But we're not going to do that. We're going to do the easy way. Self.bookings is an empty list, and when I want to book, what I want to do is for I from at until in enumerate self.bookings if at is greater than start, return false. So what am I looking at here? So if I'm got a list and the only thing in it is 10, 20, and I go 15, 25. Actually, I probably want to do a check at the beginning. If end is less than hang on, self.bookings and end is less than self.bookings 0, 1, less than or equal, then I can do self.bookings. How do I do this in Python again? I kind of want to do an insert at position 0, start end, return true. So that's kind of the case of, here's another one here. We have no bookings. Except the one booking we've got. If this thing ends before our first booking, insert at the beginning. Otherwise, what we want to do is we want to start working our way through. So for each value at until, if at is greater than start, if we've made it this far, and at is greater than start, no, hang on, I've got to be a bit more careful here. So what are the cases? What's the actual cases here that we need to worry about? If we look at this as a number line, let's say I've got a booking here and I've got a booking here. Cases are, I'm looking here to, let's say, here. This one is okay, handled above. Then let's say I've got something that starts here and extends to here. Not okay. And then there's another one which looks like this one, which is not okay. I'm gonna need a few more spaces just while I'm here. If I'm able to go here to here, this one's not okay. But if I start here and go to here, this one is okay. So what's the differences here? So basically, if I'm looking at this particular booking here, it's okay because it was handled above or earlier, let's say. Yeah, what do I actually want to do here? No, I think I want to do this slightly differently. What I actually want is to find the windows where it is okay. So in fact, the valid windows is self.bookings for at until in self.bookings prev 0 valid windows dot append prev at prev equals until valid windows dot append prev 10 to the power of 9, let's say, because that's the end. So then what I want to do is for I free start, free end, enumerate valid windows. Basically, if in some window I can find space to slot this, then what I want to do is, so if start is greater than free start and end is less than free end, add to bookings, return true. If we make it all the way to the end without finding somewhere to put it, then we're done. Now, we know something a bit special here. Basically, if I know that I found this at window, so let's say our bookings looks like 10 20, and I'm trying to insert 2030. This last one, then what I know is, sorry, before I go any further, so this is bookings. Free things are 0, 10, and 20, 10 to the power of 9. If I'm trying to insert 15, 25, then do better here. If the free start is greater than the end, we should have found something by now, so stop looking. Anyway, so if I'm looking for 1525, I'm not going to find it there. I'm not going to find it there. So I'm going to fall off the end. If I'm trying to insert 2030, this will work. So 0, 1, I know this is index 1, so I need to insert this thing at index 1. Does that work? Let's tidy this up a little bit. So I have a list of bookings. If that list is empty, then insert the booking. We know it's fine. If otherwise, let's find all the times when we're free. At until in self.bookings, valid windows.append prev at prev equals until valid windows.append prev 10 to the 9. Okay, so what this does is it goes through and says, okay, for the first one I'm going to do 0 to 10, then I'm going to do 20 to 10 to the 9. Now I'm going to start going through those free chunks. If the start comes after the start of a free chunk and the end comes before the end of a free chunk, then we're okay. Insert the booking, return true. If the free start comes after the end of the event we're looking for, so say that this free chunk starts at 30, but I'm trying to insert something that ends at 25, and I haven't already been able to insert it, there's no point searching any further, return false. And if in fact you get all the way to the end and you haven't found a place to put it, return false. Now obviously it'd be nicer to maintain this list, but we'll come back to that if we find it's a bit slow. Cool, that works. Let's use all the example test cases. Is that the only one? That's slightly annoying. Well, let's give it a submit, and if it tells we were too slow, we'll start maintaining the free windows specifically. Wrong answer. Ooh, that's not good. Oops, wrong button. It's not what I intended to do. This is what I intended to do. So, null, true, true, false, false, true, false. Ooh, there's something happening on this one. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 19 to 25. I've said false, but I should have said true. Let's try setting that to be equal. That works. So is it this one? Why was 19 to 25? We've got something from 25 to 30. Oh, because it ends at 25. Just. Okay. It starts at 25. Let's try it. Didn't look like we were having speed problems though, which is good. Yeah, great. Got it out. Perfect. So yeah, as I was saying, one option would be to maintain the free slots specifically. So start with the free slots containing 0, 10 to the 9, and then when you have a new element, you want to sort of slice and dice. If you'd find a free window that fits in, and you'd split that free window into everything up to and then everything after. But that's a little bit more complicated, so let's not do that. This works fine. I think that's where I'm going to leave it today. Thank you very much for watching, and I will see you all next time. Bye.